Next is question B. The question B is 4 ln times cos inverse 5w. Okay, so let's say y equals to 4 times ln cos inverse 5w. Alright, so for this question, we are assuming that cos inverse 5w is inside the ln. Okay, we assume like this. Okay, because actually this question is not very clear because we don't know cos inverse is in which part. So I just assume that cos inverse here is in the part of ln. Alright. Okay, so this one, for this question, we need to apply chain rule. Okay, let's say the question is dy dw equals to so 4 you just bring it forward, ln you get 1 over cos inverse 5w. Okay, and then we differentiate cos inverse. So the formula, so it is negative 1 over square root of 1 minus 5w squared. And then finally we differentiate 5w, that is you get 5. Right, so as you can see here in this question, we have to differentiate many times. First we have to differentiate this ln, and number 2 cos inverse, and number 3 they have to differentiate 5w. Okay, alright, and then we simplify the answer. Okay, that is negative 20 over cos inverse 5w times square root of 1 minus 25w squared. Alright, okay, done for question B. Okay, now we move to question C. So question C is y equals to cos x power of negative 1 plus cos inverse x power of negative 1 plus cos inverse x power of negative 1. So as you can see here, it's a bit confusing lah. Okay, but you have to know lah again that cos inverse x is not equal. It's not equal with 1 over cos x. Okay, so today, so what we'll do is we'll differentiate one by one. So dy dx equals to, so first differentiate cos x power of negative 1. So this one is a composite function, so we need to apply chain rule. So differentiate cos, you get negative sine x power of negative 1 times differentiate x power of negative 1, should get negative 1 over x squared. Okay, plus, and then we have cos inverse x power of negative 1. So again we'll apply chain rule. So negative 1 times cos inverse x power of negative 2, and then differentiate cos inverse x, we shall get negative 1 over square root of 1 minus x squared. Okay, and then plus the third one, cos inverse x power of negative 1. So differentiate cos inverse, you should get negative 1 over square root of 1 minus x power of negative 1 squared. Okay, and then differentiate x power of negative 1, should get negative 1 over x squared. Right, after that you simplify this question. Okay, I think on this part you can just multiply with the on this part you can just multiply the negative sign, and then this part also just multiply, but then this one you have to simplify. Okay, on this part you have to simplify. I think you can do on your own. Okay. Okay, next question is question E, where we have y equals to e power of sine inverse square root of 3x times tangent inverse 4x. Okay, so to solve this kind of question, first there's two methods. Number one, you can differentiate directly and using product rule and also some chain rule, but you can also use logarithmic differentiation, okay, where you add a log in both sides in order to simplify this function. Okay, let's say as if you remember, we can apply the log differentiation if the question is in terms of multiplication or division. So in this case, it is in terms of multiplication. So let's say we try to use or to solve this question by using logarithmic differentiation. Okay, so let's add ln. So ln y equals to ln e power of sine inverse 3x times tangent inverse 4x. Okay, so ln y equals to, so this one we expand. So ln e power of sine inverse 3x plus ln tangent inverse 4x. Okay, number one, you must know properties of log. Log e power of x is also equals to x. Alright, so this for this part, ln e power of sine inverse 3x, so it is equals to sine inverse 3x. Okay, so you should get ln y sine inverse 3x plus ln of tangent inverse 4x. Okay, so this one we have simplified the question using properties of log. Okay, now we can differentiate this. So ln y equals to 1 over y dy dx. Differentiate sine inverse, you should get 1 over square of 1 minus square of 3x squared. Can then differentiate square of 3x. You should get 3 over 2x power of negative half, right? Okay, plus differentiate ln, get 1 over tangent inverse for x, and then differentiate tangent inverse, you should get 1 over 1 plus 4x squared, and then finally differentiate for x, you get 4, right? And then you simplify the answer. Don't forget to bring y to the right side. So I make a shortcut here. So y, I straight away write the original question. That is e power of sine inverse 3x tangent inverse for x times 3 over 2 times square root of 2 square x times 1 minus 3x plus 4 over tangent inverse for x times 1 plus 16x squared. Okay, alright, so this is the answer, okay, of this question E. Okay, and then this is the final question for this topic of derivative of inverse trigo function. Okay, that is question number 3. Find dy dx in terms of x and y. Okay, this is in terms of implicit differentiation. Okay, first we put d dx both sides. Okay, and then use differentiate using, I think here you have to use chain rule and also quotient rule on the left side. Okay, differentiate tangent inverse, you should get 1 over 1 plus y over x squared, and then differentiate y over x, we need to apply quotient rule. So x times differentiate y dy dx minus y times 1 over x squared. Okay, equals to, differentiate ln, you get 1 over 3x cubed minus y cubed. Differentiate 3x cubed minus y cubed, should get 9x squared minus 3y squared dy dx. Okay, alright, and then I think for this part you have to simplify. You have to simplify. Okay, you have to simplify. If you simplify this, I think you should get x plus y. I think you should get x squared over x squared plus y squared. This is what you get lah. If you simplify this part, 1 over 1 plus y over x squared. Okay, you should get x squared over x squared plus y squared. Okay, right. So let's say I expand this. Yeah, I think we can cancel lah kot. This part and this part. So ni cancel dengan ni. Kan? So I think also this one you can multiply. So if you multiply, you should get x over x squared plus y squared dy dx minus y over x squared plus y squared. Okay, equals to this one also you expand. So 9x squared over 3x cubed minus y cubed minus 3y squared over 3x cubed minus y cubed dy dx. Okay, and then we separate the one with the expression with dy dx and the one without dy dx. Okay, so maybe you can factorize that directly. Dy dx x over x squared plus y squared plus 3y squared over 3x cubed minus y cubed equals to, and then this one bring to the right side. So 9x squared over 3x cubed minus y cubed plus y over x squared plus y squared. Alright, and then you can cross multiply dy dx equals to x times 3x cubed minus y cubed plus 3y squared times x squared plus y squared over x squared plus y squared times 3x cubed minus y cubed. Okay, so on the right side we have 9x squared times x squared plus y squared plus y times 3x cubed minus y cubed. Okay, over 3x cubed minus y cubed times x squared plus y squared. Okay, finally you can divide. Okay, I think finally you can divide. Alright, I write here the answer because I have limited space here. Alright, so in the end, I think you should get dy dx equals to, if you divide, you should get okay, it's a bit long. So 9x squared times x squared plus y squared plus y times 3x cubed minus y cubed over x times 3x cubed minus y cubed plus 3y squared times x squared plus y squared. Okay, alright, this is the answer. Okay, so that's all from me for this topic. I'll see you for the next chapter. Thank you very much.